This was the old table, or this is the old table, or the wood from the old table that I'm about to put into a new project, a new TV stand. Now, near Hatton Shale I never really liked it. It was put together quickly without too much thought. So I just thought I'd do a little exercise today based on design and just the basic introduction to the design principles. When you go to do something new, you always need, I suppose, a plan. You need to know the rudiments of design. You'll find that most items that you'll ever buy in shops or anywhere for that matter, nearly everything is square, and there's a reason for that. It's for structural integrity. So there's always the thing about shape and form is the two sides of the same kind, I suppose, as some might say. It's the two cheeks of the same backside that would always be bandied about from the point of view of design work. So if we say Oscrailge Cadahani Gerduis on Sikino and Uv, we have this situation here: which comes first, the chicken or the egg? Is it shape or is it form? Well, in actual fact, it's both. Shape relates to, if we take it just simply, very basically, is two-dimensional. So a sheet of paper is two-dimensional there. It is simple plane. It has no third dimension, so therefore it's not structurally solid or it's not meant or designed to support a load, what's called a load. So then, that's shape. If we take the shape of that and we actually roll it, well, we can roll it into, and I have one here, of course, we roll it into a cylinder like this. That cylinder now has structural integrity. It's two-dimensional, but it's actually three-dimensional from a distance. It only has a height and a radius, but technically it's three-dimensional. If we take that there, we can then take maybe a pad and put it on it. Now, it has gone from shape, it has changed its shape and it's changed its form, and it now has structural integrity. What that means is it can support a load. And that's just a little thing I want to talk about. When we want to come up with shapes in design or in furniture or in anything, the built environment, anything to do with the built environment, we need to be aware of the chicken and the egg. And it's a metaphor I use time and time again, or analogous to this here: chicken or egg, which came first? So three shapes that normally are used in the design process. One is the square, the second one is the triangle, and the third one is circles, or related areas to circles, like ellipses or parabolae or whatever. Don't want to go down there just now. We can do that at a future date. But when it comes to triangles with square, you'll notice most tables are square. Why? Fast produced, structurally, they have the structural integrity, strength, and then it's easy to accommodate people underneath it. That's part of the ergonomic cycle as well. Again, a topic to be debated and to be looked at down the line. When we come to triangles, and I'm taking a triangle in my case here to do the design for the new table. When it comes to triangles, everybody knows, just in simple fact there, that if I take a triangle like this here and I place a load on it, that on camera there, if I press down hard enough, the actual load will come on there and the legs will spread apart, or the rafters. So think of that as a roof. So in order to make a roof, if a roof it's only just like that, what's called simply supported, and sits on wall plates, in order to make it strong, it'll spread apart if we put the load on it, too much of a load. So in order to make that structurally stronger, we can put what's called a collar across. Now, when we put that and we press on that, it has much more structural integrity. So the triangle is a very, very strong shape. That's why it's used predominantly in roofs. So that's a triangle, simple thing that happens with a triangle. When a downward force comes on a triangle like that, the force is acted downward, the vertical force downward sends an arrow. It displaces the load down along the sides. And this guy here will counteract that load. So it'll have a tendency to resist the pressure to actually come apart in both directions. So if we do that there, we put an arrow. That's what happens with the load physically. When the load comes on, the load is transferred down along this and it's pulled back here. So this particular member is being stretched. So there's only two things in relation to this. We've got what's called compression and tension. And the bottom one, this one's being compressed, it displaces the load, and this one here resists it pushing out, and therefore it pulls it back in, so it resists the tension to pull apart. So a triangle is a very, very strong structural shape that we can have. Now, if we just add one more member, so that's now why am I mentioning all this? Because when you go to make something or to design something, you need to understand the actual, what the product is going to do, the end result is going to do, and is it structurally sound and applicable or suitable for its purpose, fit for purpose, I should say. So if we tap that guy there, now we've got this guy in a vertical position here, or close on it. Okay, this is just a model. So now we've got the two triangles. Now two triangles is always going to be stronger than one triangle. And what happens there is with the loads now, the load force comes down and each triangle operates independently of the other one. So what we do is, when we're dealing with what's called triangulation, we start with one. If we break it into two, now we have more structural integrity. So the force is acting on it, comes down here, it's forced in, and this guy does the opposite. It pushes. It counteracts the compression going down it. So now you've got a triangle. Now you've got the load triangle. You've got it coming down, being pulled back in and going back up. Same thing on this side. So that is extremely strong. That's a very strong structure. Now, what I just want to get across is that that's the old table. We're going to recycle what we already have into a new project to support another television in this case. So just to recap, we always have to ask the question, Cada hánig ar dús an sicín nó an egg, or an is it the chicken or the egg comes first, shape or form? And I've just outlined that with a plain piece of paper. When we change its shape, we change its form, and we give it its structural integrity. So as I say, I've got this piece over here, and my final design is over here, and I'll show the transition of that into reality as we go forward. Agus sanis go dtíon céad ó riile slán go fóill. So until we meet again the next hour, bye for now.